Recall a Quasi-Bessey sequence of order 16 has this form right here. So what does this one look like? Well, if you've watched my video on Quasi-Bessey sequences that uses the law of attraction narrative, and that particular performance gets a wonderfully strong response from the spectators that I've shown it to. And we'll see why in just a moment, because the Surprisal value for that routine is very high. So what they're witnessing there is extremely unlikely, given the assumptions that they have in their minds about what they're seeing. Okay, so what does it look like? Well, here it's 16 random cards are chosen and noted. After thorough mixing of the 16 cards, they are divided into two piles of 8 cards that match a written prediction. So in this particular case, you would just deal out 16 random cards. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's fine. And then you can have the spectator mix these to their heart's content. Okay. So these will truly be random cards, and they can be chosen by the spectator. In fact, ideally that should happen. Okay. And so in what I'm describing here, what a person would do is just kind of show those cards to the spectator, and it will help convince them that they've chosen a nice random selection of cards, colors and suits and values. And then you just tell the spectator, okay, I'm going to just quickly write down which cards you selected. So for example, for 7 of hearts, you can just write 7H. Now secretly, what you're writing down in one group of 8 cards, and the other group of 8 cards will make up the remaining cards, is you're following the Quasi-Bessey sequence structure right here. So the ones will be put into the same group, and the zeros, the remaining cards, will constitute the second group. Okay, so in particular, what this means is the 1, okay, that would correspond to the card in the first position here. So on our piece of paper, we would write down 7 of hearts, and then we'd come over here to 5 of spades, and then we'd come over here, king of diamonds, jack of diamonds, and then we'd skip those 2 and then come over here, 8 of hearts, queen of diamonds, skip 1, come over here, 9 of spades, and then queen of hearts. So that will constitute one of the 2 groups at the very end, guaranteed. Okay? And then the other cards will make up the remaining pile of 8. Okay? And now these cards are then thoroughly mixed using all of the many shuffles that preserve Quasi-Bessey sequences of order 16. Okay? And there's many, many of them. Okay? So after tremendous mixing in which the spectator is dictating just about everything, you come back and then you deal these out kind of randomly into 2 piles. Well, secretly what you're doing is you're just rebuilding this again. So you're doing, like, you can put the 1s here and then the 0s here if you like. So you can go 1 0 0 1 0 1 1 0 0 1 1 0 1 0 0 1. Now, if you do that, that will look extremely random to any observer. But what you've done is you've pulled that sequence apart again, because this structure was preserved by those many, many, many shuffles that you put it through. Okay? Now, from the point of view of the spectator, what kind of level of surprise would they experience in watching you do all of this, and then you show the identity of, of the piles here, and they match what's written for your prediction on your piece of paper? What degree of surprise would the spectator experience in witnessing that? And what would be the equivalent way to view that surprise in terms of ordinary coin tosses? Well, that's where our Desmos activity comes in. So let's go back up here again. We just have to adjust our sliders. Okay, so all of the same information applies. Okay, the only difference now is that we're looking at a total packet size of 16 and we're looking at two groups of 8. Okay, so here we'll slide it over to 16. And then we're looking at selecting 8 at a time. That's what we've done. So if we come down here, we can see the following. In fact, perhaps we should move up to the number of possible outcomes and the probability itself. So let's back up for a second. So how many ways can that be done? Given 16 objects, how many ways can you choose 8 of them, where you're not worried about the order in which those 8 objects are chosen? Well, here it is. So it's 12,870. Well, to get the probability that you would just randomly guess the exact grouping at the very end, the groupings here, that would be 1 divided by that number. So very, very small. Now that number is so small that how would you even interpret that? Well, that's where Surprisal theory comes in and gives us a very concrete way of interpreting rare events. Okay, so let's come back down here. Okay, so what we're looking at is the level of surprise associated with witnessing this performance being done successfully is 13.65 bits. Okay, so what's our interpretation? Well, I suppose we could round this up to 14 bits. That would be reasonable. So the interpretation here would be that the surprisal level or degree of surprise in witnessing the successful completion of this routine, where you're able to predict ahead of time the exact cards that make up these two piles after all of the, quote, randomization, it's the same level of surprise one would experience in witnessing 14 fair coins being tossed high into the air, and while in the air, that person calls for heads on all of them. They're all going to land heads up. And then the two of you watch the coins land and bounce and settle down, and eventually every one of the 14 coins is heads up. The degree of surprise associated with witnessing that random event is the same or very similar to the degree of surprise one would experience in watching a successful completion of this performance here. Okay, so that's very, very unlikely. And then, of course, down below, once again, we have a table of values. We have a graph of the Surprisal function. There we go. And we can also, I guess we need to click Show All. The particular one that we are working with, because we're breaking the packet of 16 cards into two piles of 8 cards, is here is our Surprisal value. And as you can see, that's where the maximum occurs. So we hit maximal Surprisal for what can be done with this packet of 16 cards when randomly choosing a certain number of them, but being able to predict what those cards are in the end. Okay, so there is our Surprisal value.